So hello, very welcome again. So in our previous module, we talked about the resistor and a capacitor circuit, that is an RC circuit. In this module, we will focus on a circuit that will consist of a resistor and an inductor L. So remember, this L was capacitor C in our previous model. So instead of inductor, we used a capacitor here. Okay. So right now, what we see here, you have an input signal V in as an input to this network of R and L, and we have an output of this network VO. What is an input signal here? We apply a step input that is switching between a level of 0 volt to a level V in. So V in can be any value, let's say a 1 volt or let's say a 5 volts, something like that. It could be like that. So you have a low level of the voltage and you have a high level of the voltage. And interesting part that we want to understand here, how inductor behaves in this situation. So let us say you have an input signal 0 volt, V in is equal to 0 volt right over here. Let me write here. V in is equal to 0 volts. So what you see, there is in fact no input applied to the circuit. And inductor, we say that there is no current that is initially flowing through the inductor I. Therefore, it is not energized. We say that the inductor is de-energized. And we also can say that it has reached a steady state condition. So in the steady state condition, this inductor acts as a short circuit. It acts as a short, which you can see that we see in this part of the circuit. So when your input is 0 volt, you have a resistor and inductor is acting as a closed circuit, that is a short switch. And obviously the I that can flow in the circuit, but since there is no input, your I is equal to 0 ampere. You don't have any current flowing here. And obviously your current here in the circuit is 0 because the input signal applied is 0. VO, which is taken across this inductor, is obviously 0 volt. So you simply say that V in is 0. There is no input to the network. There is no output of the network. And current obviously is also 0 ampere. So we see that the voltage across the inductor is VL, which is nothing but a voltage output of the network. VO is equal to 0 volts. And what about the VR? VR is the product of current multiplied by the resistance value, I times R. And obviously there is I is equal to 0. There is no current into the circuit. Your VR, which is actually I times R. And obviously, since the inductor is short, V in is equal to VR. This is the voltage drop across the resistor. And obviously, it is also can be said VR equal to V in is equal to 0 volts. And I is also, you can say VR divided by R or V in divided by R, 0 amp. Okay, so you see with simple analysis, we can calculate all the voltages across the components R and L, and we can calculate or determine the current in the network also. But what if when this input signal V in switches from 0 volt to V in suddenly? So in practical circuits, this switching time is not exactly 0. Okay, let's say at t equal to 0, you have a V in is equal to 0 volt, and at t is equal to 1 second, you switch it to a high level. So that it will take some switching time, that is called as rise time of the circuit. rise time of the circuit. So you basically have, in practical, you have a pulse or the step input that will look like this. But in practical, in the ideal condition, we say that, okay, it's switched between 0 to V in. So when your V in is now at a high level, the property of the inductor is that it opposes a sudden change in the current through it. So what is the initial current that was flowing through the inductor? Obviously, we calculated it was 0 ampere. So inductor will oppose that flow of current, because now you don't have a zero input here. You rather have V in is equal to high level. Okay, it could be 1 volt or 5 volt, whatever. So obviously the current is likely to flow through this network, that is through the R and L. But inductor will, in that momentary period when you have a switching from 0 to high, inductor acts as open and it will not allow the current to flow through this network, through it, and therefore the current will not be allowed to flow through this network. So we will say the output in that case, VO, is equal to V in, because inductor is open now. So this voltage right here is appearing directly across the output. There is no current through the through the resistance R also, because I equal to 0. So voltage drop across this resistance also 0. So whole input V in is coming here. This is called as transient state of the network, where I is 0 ampere and obviously I is 0. Multiply it with the value of resistance. So drop across the resistor VR is also 0. Okay. However, once this transition moment passed and your input has attained a steady value of a high level, let's say 1 volt or 5 volt, whatever. Now you have a constant voltage which is not equal to 0, and your inductor is now again acting in its steady state mode. It will act as a closed switch, which it acted as if there was no input. So when it acts as a closed switch, obviously you see that the circuit got completed. Your current I can flow through the resistor R, creating a voltage drop across it VR, and inductor, obviously the voltage across the inductor can also be calculated here. So you see that you see that this VR is equal to V in. Here you can see that I is equal to V in divided by R, and VR is I times R, okay, and which is equal to V in. And the output voltage is also equal to V in, or you can also say that it is equal to VR. Okay, so this is how the inductor behaves and makes sure that the voltages and the currents can be calculated. Case B. I hope you are getting me. It is very simple network. If you are new and you want to refer to our previous module where we have only resistor and the capacitor, instead of inductor we have capacitor. So refer back to that module first and come back here again. Now let us say if I switch the position of inductor and resistor, I swap the positions. So instead of R, I have L, and instead of L, I have R. I have applied input switching from 0 to V in, and I am interested in knowing the voltage VO, which is now across the resistor R. So initially I have V in is equal to 0 volt. So I am looking at this network now. So no input to the applied to the network, and inductor is assumed to have reached its steady state. We assume that the initial current, there is no initial current energizing the inductor L, creating a magnetic field surrounding it. So we'll say that IL is equal to 0. IL is equal to I here. So obviously there is no input to the network, output will be 0. And the current also is 0. So IV in by R is 0 ampere. VR is equal to VO is equal to 0 volt. So this is your initial steady state condition. Okay. Now let us assume that, let us see how your circuit will behave when you apply now a high voltage. So your input is switching from 0 to V in. So during that switching period, so where input signal is switching from 0 to high level, that is called transient period. Inductor has its property to oppose sudden change in this current flowing through it. So initial current through the inductor was 0 ampere. It will like to have the same amount of current through it. It will not, and to do that, it will act as an open switch. So there is no current flowing through this inductor and hence to the network. Again, I is equal to 0 here. Look, I is equal to 0. So that's the behavior of inductor. Since now you have switched it from 0 to 5 volt or V in levels, or even then your transient period causes I equal to 0 ampere, and obviously there is no current through the resistor, so no drop across the resistor, and which is the output voltage is equal to 0 volt. However, once the transient period is over and your input has reached a constant value here, so your input is now a constant value of high voltage. Inductor acts as a closed switch. It is now a steady state. The current will flow through the network, through the inductor, through the resistor. Inductor will get energized. It will create, there will be a magnetic field in the coil. There is a current flowing through this I, creating a voltage drop across resistor VR, which is nothing but output voltage. So we have written VO is equal to V in is equal to VR, that is steady state. And current I is obviously the any voltage divided by the resistor. So this is an interesting behavior of the inductor, and we have also seen an interesting behavior of the capacitor in the previous module. Refer back to that module and hope you benefited somehow with this knowledge of RL circuit and RC circuits in our previous two modules. And if you benefited so, if you feel so, if you have liked this module, click the like button, share it with others for a wider reach, and stay tuned for more informative, engaging engineering concepts in the field of electronics and technology. And till then, wish you a very happy learning.